Hey everybody. Some people want to learn how to do Geometer SketchPad, and it's a handy thing to be able to do. I'm going to kill two birds with one stone. We're going to discuss inscribed angles and congruent triangles while we have SketchPad. So here's a circle maker. This is a program that's on the Aquinas intranet, so you can use it for free on Aquinas at Aquinas. So let's make an angle, an inscribed angle. See how when you move your arrow towards an object and it locks that point into place. Isn't that handy? I'm going to do that again. Watch, I'm just moving around, but when I get on that green circle, the circle turns red, and that's Geometer Sketchpad way of saying, hey, do you want that point to be on this circle? And I think, yes, I do. Now here's the beautiful thing about Sketchpad. I've made these points stick to the circle. All I'm doing is dragging them with the mouse. That's it. So let's check out another thing that's pretty handy with Geometer Sketchpad. We might be able to measure an angle. Click on the vertices in the order you want the angle measured. So measure angle. And this is a typical thing. Look at this menu, how most of the things in that menu are not activated. Because I clicked on 3 points, measure an angle is active. Now I'd like to also measure an arc. So I'm going to stick a dummy point in here, and I'm going to measure this arc from here to there to there. Let's see if it will let me measure the arc. No, I think I have to I think I have to create the arc. Let's do it this way. Let's do this. Construct arc through 3 points. Now with that arc selected, every time you make something in SketchPad, it's selected. Do you see this little ghostly outline of that arc? Now we're going to measure the arc. Let's do the arc angle. And the angle ABC looks like it's half of this arc. Let's see if that's the case. Yeah, there's 49 and 98. There's 63 and 126. Yeah, the inscribed angle is half the arc. Now, an interesting thing happens as I come down here, and this angle, notice it's still 100, 200, but what's happening is this side AB is getting closer and closer to being tangent. So let's measure the tangent at that point. So what you want to do is construct. Now the tangent to the circle goes like this. The tangent's going to be the point that's perpendicular to the radius at that point. So when I go to stick the tangent in there, construct perpendicular. Okay, let me stick a point on here. I'm going to measure this angle from there to there to there. Let's measure that angle. And there is a point to what I'm about to do. Let's watch the measure of angle ABC compared to this EBC that is not going to move. As A approaches the point B, the angle ABC should be approaching 102 degrees, with the tangent being the limiting case. See, I'm just getting over 100. I'm at 100.5. I'm at 101.93, just as A merges with B. So that's not a math proof. For a math proof, that'll probably be on one of the wikis one of these days. But so here's the deal. The angle EBC counts as an inscribed angle for the arc that goes all the way around BAD to C. And so the angle is half that arc, just like it usually is. Now, another thing that has been coming up is congruent triangles. So let's do a new sketch. Let's say I have a pair of triangles, and I'm gonna build kind of wisely here. I'm gonna make a circle with center here, that size, and I'm gonna make a circle with center here, that size. So where those two circles intersect, I should be making a copy of the triangle that I just made at random. So these two triangles that I just made should be congruent. I'm going to hide these two circles that kind of guarantee that they're congruent, hiding them. And if I change this triangle, the other one changes in accord with that. That's kind of cool. And it certainly looks like these two triangles are forced to be congruent to each other. Now let's see what it means to be congruent to each other. Here's what it means. I'm going to measure this segment right there. Let's measure that segment. Its length is 4.02. Let's measure this segment. Its length is 4.02. Let's measure this angle. Boink, boink, boink. Measure that angle. That angle dBA is 63.4, and you can bet your buttons that dBC is going to be 63.4. Yep. And we knew that going in. We knew because this angle right here, dBA, this angle that I'm going to mark, that angle is the same size as this angle. But it's also the fact that they correspond. They're in the same relative location on both triangles. There's a lot of the people who have read the book, but they don't appreciate the power of this idea. Corresponding angles of congruent triangles are equal, or congruent, whatever way you want to say it. How come this isn't appearing here? Oh, I'm on the wrong keyboard. I wrote it on the wrong keyboard. Anyway, so corresponding angles. Corresponding angles, they're going to be the same size. That means this angle at C, this angle at A, they're going to be the same size. These two skinny angles up here at D, they're going to be the same size. Corresponding sides are the same size. So what happens is we say corresponding parts of congruent triangles are congruent. And if you read the book, you'll see that invoked many, many times. You can abbreviate it, CPCTC. I've mentioned it a few times on the wiki. We'll mention it a few more times in the future. So that's the business of using SketchPad. These buttons over here are for making things. This cursor is for selecting things. And depending on what is selected, like if I wanted to select this, I can come up here and I can get a midpoint. And there's the midpoint of the side that I selected. Now if I select this side and come back up to construct, I can get the perpendicular bisector, and I can also change its color. So I've got this orange perpendicular bisector of the side DC. And what's beautiful is, even if I move the points around, even if I move the triangle structure around, that orange segment is still cutting the triangle DB, or that side DC, just right. And look, the corresponding angles, 15.61, 15.61. The corresponding sides, 9.35, 9.35. Those things stay equal. So in SketchPad, you make something with a structure, that structure stays. All right. The only other thing I was going to do is show you that if you don't want to work on SketchPad, you can work with a drawing compass and Straightedge, which looks like this. If you didn't buy one of these, you're going to have to borrow from me or somebody else. Check it out. Okay, so I've got a drawing compass, and I've got a ruler, and we're going to show you how you use these things. Now, look at my handy-dandy compass. I can actually put pens and pencils in it. I can make a green circle. That looks pretty easy. Let's observe what just happened. I used the compass like this, but underneath this sheet of paper, I have many more sheets of paper so that the point digs in and stays. I can also see that point, and I can emphasize it with my pen. And now if I go anywhere on this circle, I can go this way. And what I just made was, if I mark the point that I just used, because there's a little piercing in the paper, I can find that point. And these 3 points are the vertices of an equilateral triangle. So if I took my ruler and drew along from there to there, and drew along from there to there, and drew along from there to there, I'd have an equilateral triangle that I just constructed with very little work. So this is what you can do for your assignments. You can build on paper, take a picture, and pop that onto the wiki for full credit. All right, well, stay tuned for other highlights. I know it's only been 9 minutes, but I don't want to bore you. Send me your questions and I'll make more videos for you. Bye-bye.